Good morning, guys.
Good morning, sir.
Morning, sir.
Let us wait for 2 more minutes. Meanwhile, what you can do, you can think upon this problem. Okay, it is an ICR problem. Try to solve it. So we will start its solution after 5 minutes. Okay, meanwhile you try. Okay, so I hope you have started the solution. Okay, now let us see the you can tally your approach, that how you started, what you wanted to find out, okay, and how to go about the solution. So I'm reading the statement of the problem. C is a uniform cylinder. Okay, so you can locate where is the C. So this round object is a cylinder which is uniform. Okay, to which a rod AB is pinned at A. So rod A, where is the rod AB? Rod AB is here, A, B. Okay, so this rod is pinned on the cylinder at this point. What does it mean? That there is connection between cylinder and rod at point A. Okay, how is that connection? So the connection is like this. Suppose there is the cylinder and this particular rod is connected here. You can say with the help of a pin or bolt, nut and bolt, like that. So because of this pin connection, what is happening, that this rod can have angular motion about this point A. Okay, as the cylinder will roll, okay, and depending on the connection of rod AB, this rod AB can turn about this point. That is called as pin connection. Okay, so it is mentioned here that rod AB is pinned at point A, and the other end of the rod B is moving along a vertical wall as shown in the figure. So this point B is just resting on this vertical wall. It is a vertical wall here. Okay, this is a vertical wall, and the point B is just resting on it. So what will happen when, say, the cylinder will roll like this? The point A will move here, okay, and the point B will move upward or downward depending on position of the point A. So the point B, which is here, it can have the velocity. It can have the velocity in the linear direction, velocity of point B. It will slide. It will slide along the wall because it is just leaning against the wall. It is just resting on the wall. There is no like a fixed connection over there. Okay, so I hope you are getting how the motion will take place. Next is, if the end B of the rod is moving upward, which I have shown like this, along the wall at a speed of 3.3 meter per second. So the point, it is given that point B is moving upward, okay, at what rate, at what velocity? That is 3.3 meter per second. Find the angular velocity of the cylinder. Means what you have to find out? Omega. Angular velocity means omega of cylinder. So you know that we are denoting cylinder by letter C. Okay, the omega C. We have to find out it. Angular velocity of the cylinder, assuming that it is rolling without slipping. So the cylinder is purely rolling. Okay, there is no slipping happening. Slipping means what? The point of contact will drag along the surface. Okay, but in rolling, what happens? Every instant, the point of contact will change. As the cylinder will roll, new point will come in contact with the surface, and then it will become the ICR. Because when rolling happens, the point of contact between rolling object and the surface is your ICR. Got it? Okay. So with this setup, what we are given, the angular velocity of point B, which is on rod AB. What we have to find out? The angular velocity of C. Means कहाँ से आना है हमें? We have to come from point B to this point B to cylinder. So in between, we will have to find out many things. Like when you will be coming from point B, then you will need to find out what is then angular velocity of the rod AB. Okay, then after angular velocity, you will find out what is the velocity of point A. Okay, and then later on, after finding velocity of point A, you will find out the angular velocity of cylinder. So the flow will be like this. First you find out angular velocity of rod AB, then you find out velocity of point A, and after that you find out the angular velocity of the cylinder. Okay, so for doing all, you know that first of all what we do, we locate ICRs. We locate the ICR. Okay, and number of ICR, how many ICR will be there, it will depend on how many objects are there. So you can see there are two objects. One is rod AB, okay, and one is the cylinder another is the cylinder, that is C. So we have to find out the ICR of rod AB, okay, which say I we will find, and later on we have to find out the ICR for the cylinder, that about which point the cylinder is turning. Okay, so if you remember that when any object rolls over any surface, then point of contact indeed is the ICR of that rolling object. Correct?
Correct.
Mute all of you. Okay, so I was telling you that we have to find out the ICR for rod as well as for cylinder. Two objects are there. So for cylinder, we know that for a rolling object, the point of contact between object and the surface is the ICR. So I can easily locate one point here. I will call it, say, ICR 2. Okay, or IC, I can say. IC means ICR of the cylinder. I can denote this point of contact as I2. So ICR for cylinder is I2, and ICR for rod AB, I will denote it as I1. Okay, so now how to locate? We have located the ICR for cylinder. We know that for rolling object, the ICR is the point of contact between object and surface. But what about rod AB? How to locate the, how to locate the ICR for rod AB? Rod AB का कैसे ICR locate करोगे? How you will locate it? Do you know any concept you have learned in the previous classes? Okay, so I will explain it. We know this concept that velocity is perpendicular to radius. Okay, and you know that velocity has certain direction. So if we draw perpendicular to the direction of velocity of any point, okay, we can find the ICR of that point, right? So we will be using this. So you tell me which point velocity, which points are there on rod AB. Obviously, if you want to find out the ICR of rod AB, you must consider the points which are located on rod AB. So which points are located on rod AB, A and B? Out of that, we know the direction of velocity of point B, which is already given to us, that the point B is moving upward. It is moving upward along the wall, BB. So if we draw a perpendicular to the velocity from point B like this, okay, I am going to get the ICR on this line somewhere. Okay, no doubt this line can also be drawn in opposite direction. Instead of left, I can also draw it right side. Okay, so initially I don't know, but I have drawn it. Okay, so yeah, still we don't have the ICR. So what we will need? We will need one more point, velocity of one more point, that is velocity of point A. So can anyone tell that in which direction point A is moving?
Tangent to C.
Tangent to C, correct. Okay, so point A, if you see its moment at this particular moment, okay, this cylinder is turning like this about point I2. So point A will go tangent to the circle, obviously. Okay, so I will draw a tangent to the circle, okay, like this. It can be left also, okay. I don't know initially what is the direction, I don't know. I can also draw it left, okay, because I don't know the cylinder is rolling upward or sorry, clockwise or anti-clockwise. So I can draw omega of, it is not it is the velocity of point A, correct, velocity of point A, this is omega is here. So it is the velocity of point A, it is tangent to the circle. I know that velocity and radius, velocity and radius are perpendicular. So I will draw the radius of point A perpendicular to the velocity, perpendicular to the velocity like this. I can also draw it downward, but from my common sense, I am knowing that if I extend this radius upward, then only I am going to meet this line, which is also in search of ICR. This line is also in search of ICR. So there will be one common point which will be on both the line. Okay, so this common point will be our ICR, that is I1. Okay, so you remember that I1 is the ICR of rod AB, okay, and I2, which is shown here, point of contact, is the ICR of the cylinder. So I2 is applicable for any point which is on the cylinder, and I1, with the help of I1, you can find velocity of any point which is on the rod, Got it? Okay. So once you locate this ICR based on your understanding of motion and few concepts, okay, next part is simple. That is just do the calculations using only one formula, that is velocity is equal to, in case of circular motion, velocity is equal to radius multiplied by angular velocity. This formula we will use for further calculations. Okay, so let us go from known to unknown. Okay, first we will see what is known to us, and from there we will move to find out the unknown. So what is given to us? That is velocity of point B is given to us. Okay, so I will write down velocity of point B. What is the formula for velocity? R into omega. So what is the radius of point B? Point B ka radius, point B ka distance from the center of the rod AB, because point B is on rod AB. तो rod AB का ही center use करेंगे. Okay, so point B का radius is distance of point B from the I1. Okay, I1 is the center for rod AB, I1 B. It is my radius multiplied by angular velocity. So which angular velocity? angular velocity of the object on which point B is there. So on which object point B is? Point B is on rod AB. So it is angular velocity of rod AB. Angular velocity of rod AB. Okay. So I already know the velocity of point B. I have to find out the angular velocity of AB. I will first find out angular velocity of rod AB. It will be equal to, okay, velocity of point B upon I1B. So did we find the radii or not? Radii find out किया हमने? नहीं ना? So radii find out कर लो. I1B is one radius, I1A is another radius. So it is simple triangle. It is a simple triangle, you know. This hypotenuse is given to you. Angle is also given. So I1B, what I1B will be there? I1B will be equal to 1.3, that is rod AB, into cos of 30. 1.3 into cos of 30. And similarly, I can also calculate I1A. I1A will be equal to AB sine of 30. Okay. So using this, AB ka length is 1.3. Okay. You can find out I1B and I1A. Tell me the values.
Sir, I1B is 1.125 meter.
1.125 meter. And I1A is
0.65 meter.
is 0.65 meter. Okay. So here we have angular velocity of AB. Velocity of point B is given here 3.3 meter per second. 3.3 upon I1B is 1.125. Okay. That gives me omega AB.
Two 2.933 radian per second.
2.933. 2.93, right? Radian per second. Okay. So omega AB is rod. So rod ka angular velocity you have found. Okay. Next, after omega AB, what I will find? I will find the velocity of point A. Okay. So say, do you agree that point A is also on rod AB? Do you agree?
Yes, sir.
Okay.
Yes, sir.
So we will be using the ICR of rod AB. Okay. So I will write down the formula for velocity of point A. I am considering that point A is on rod AB. So rod AB ka ICR is I1. From I1, distance of point A, that is I1A is the radius, into angular velocity of rod AB. Because point A is on rod AB, we have assumed, and our assumption is right. Okay. So I1A value is given 0.65, and angular velocity of AB you just found 2.933.
1.906.
1.19. 1.1906. Correct?
1.906.
1.906. Okay, so 1.906 is our answer for velocity of point A. Okay, so sometime it may be mentioned that find out the velocity of point A, and sometimes it will not mention that find out the velocity of point A, but on the way to find out the angular velocity of the roller cylinder, okay, you will need to find out it. Okay, so it is 1.906 meter per second. Okay, it is okay by assuming or by taking, okay, no problem, by assuming point A on rod AB. Okay, also we can assume okay, point A on cylinder. Do you agree? Point A can also be assumed to be on cylinder because A is the common point. Here there is a connection between rod AB and cylinder. So you can say point A is present on both. It is a common point on rod AB and on cylinder. Do you agree?
Yes, sir.
Okay. So if we assume point A on cylinder, how we can write the formula for velocity of point A? So if point A is on cylinder, you consider the ICR of the cylinder. ICR of the cylinder C is I2. I2 is the ICR. So distance of point A from the ICR I2 is the radius of point A now. Okay, multiplied by angular velocity of which ऑब्जेक्ट, रॉड और सिलेंडर, कौन सा ऑब्जेक्ट का एंगुलर वेलोसिटी लिखेंगे यहाँ पे? सिलेंडर, बिकॉज we have assumed the point A on cylinder, so we will write here angular velocity of the cylinder. Okay, and in the numerical we have been asked to find out the angular velocity of the cylinder, which will be found by using this formula, velocity of point A upon I2A. Velocity of point A, you just found that it is 1.906, and a point distance from I2. I2A is the diameter. I can see it is a diameter I2A. So diameter is specified here. The meaning of this phi is nothing but diameter. See, this length it is showing. So phi is given, phi is the diameter. Phi is the diameter, it is a dia, 0.6 meter. So I2A is 0.6. Okay. So that will give me the value of omega c.
$12.712 radian per second.
12.712 radian per second. Okay, you can also find out whether it is clockwise or anti-clockwise. Okay, so here one can see point A, B is given to us. Okay, that it is moving upward. Point B is moving upward here. Okay, if it is moving upward and ICR is here, okay, so one can say that this motion is कौन सा motion हुआ ये, clockwise के anti clockwise?
Anti-clockwise.
Anti clockwise. So rod is moving anti clockwise. Rod is turning anti clockwise. Okay, so each and every point will have anti clockwise motion. If rod is turning anti clockwise, means point B will also have anti clockwise motion. Point A, which is also on rod AB, will also turn anti clockwise. So it is the radius of A. So you can say A point is also turning anti clockwise about point I1. So from here I will know the direction of point A, that it is moving right in right side, not in left, which initially was not known to us that what is the velocity of point A, but now we are knowing it after locating the ICR, because we got the ICR here. So point A is moving in right direction. So from point A, now consider point A to be on cylinder. Okay, so if point A is moving here and it is its radius, its radius, you can say that cylinder is turning about point I2 in clockwise direction. I2 in clockwise direction. So you can write here 12.712. You can show clockwise direction like this. It is the clockwise direction. Or you can mention, if you don't want to show this sign, you can mention here like it is a clockwise.
Sir, actually, angular velocity of cylinder is 3.177.
3.17. That is correct. It should not be 12. Here it is divided by 0.6. Yes, 3 point something. 3 point. It is a wrong answer. Okay, 3.17. Correct is the answer. So, are you getting it? The problem?
Yes, sir.
Okay. So you note it down. Also see, I will be circulating the last assignment, third assignment. I will have only 3 numericals on it to solve. 2 will be based on the ICR and 1 will be on curvilinear motion. So that will be your third assignment, which you will have to submit by Saturday. By Saturday, it will not take an hour of you. Third assignment. Okay. So these 3 assignments plus 2 practicals like this, 5 components will be there. Okay. So for today, we'll stop here. It's our last lecture.
So when will be our I?
When will be your IA? Sorry.
No, sir.
Didn't hear you.
The practical.
Viva, yes, Viva, you are telling, or oral exam.
Yes.
Can you put in chat box what are you want to say? You are getting disconnected, Bhaskar. Put in chat what you want to say. Okay, Viva. It will be on 3rd, 4th, and 5th of March. Tentatively, okay, and very close to finalization these days, these dates. It will be online. It will be online. For now, you consider it is online. Viva dates will come 3rd, 4th, and 5th March. Most probably. Reference questions, you can simply it will be on the concept. Like for example, you consider this topic ICR. So what is an ICR? What is its velocity? Where will be the ICR of a roller? How you will calculate the velocity? Okay, some diagram if the examiner wants will be given to you and will ask to locate the ICR. Okay, in this way you can prepare all the models. Okay. It will it be 1-to-1? Okay, it will depend on the examiner. So he may ask for a group of 3-person or 4-person or 4-person at a time, or 2-person at a time. May not be 1-to-1, may not be. How
Sir,
many questions can be asked? It can be asked any number of questions. Okay.
सर
Yes.
सर जो ये सब अभी आपने करा है वो आप व्हाट्सएप पे भेजोगे ना?
हाँ, ये सब भेजता हूँ मैं, ठीक है चलेगा।
अच्छा ठीक है, थैंक यू।
Group Viva means you will be sitting in groups. Like four people will enter into the room, into the meet. Okay. And the examiner will address any one of the 4, and everyone will be connected, means everyone will be listening answers of each other. Just like 4 people are there sitting in front of HR for interview, just like that. Okay, so I will close the meeting in 2 minutes. Meanwhile, you can raise if any questions.
Sir, the PDF of the 4th question solution you have sent on the WhatsApp.
This solution.
No, sir, the previous question, last lecture.
Last lecture, I think okay, it was not sent. Okay, I will check.
Okay, sir. Thank you.
Okay.